Hello everyone, I welcome you all for today's session. So in today's session we'll be dealing with different states of stresses and we'll be seeing what are complex stresses. Then we'll be seeing some sign conventions which we are going to follow in order to analyze the stress and strain. Right? So let us start with today's video lecture. So the first topic for today's video lecture is state of stress. So let me start with three-dimensional state of stress. Three-dimensional state of stress. Right? Now, in order to define a three-dimensional state of stress, let me take in order to define a three-dimensional state of stress, let me consider a three-dimensional element. Then I need to load it in all the three directions. So on both the sides it will be sigma x. Here it will be sigma y. Then in this direction it will be sigma z and sigma z. Right, so this is three-dimensional state of stress. Right, what I have done, I have just taken up a three-dimensional element and I have loaded it in all the three directions. Now, if any two values in these three stresses are prominent, and the third stress is either 0 or if it is negligible, then this state reduces to a two-dimensional state. What I want to say here is if any two stresses are prominent, and the third stress is either 0 or negligible, then the above state reduces to two-dimensional state of stress. Right, two-dimensional state of stress. So this two-dimensional state of stress is also called as plane stress. So this two-dimensional state of stress, this two-dimensional 2D, or you can write dimensional, this two-dimensional state of stress is called as plane stress. Right, so this is important. So if you are having a three-dimensional state of stress, if any of them is 0 or negligible and the other two are prominent, then the resulting state will be two-dimensional state, also called as plane stress. Right, the associated strain you called as plane strain. The strain caused due to plane stress is called plane strain. Right, so I hope plane stress and plane strain are clear. Right, now there are two types of plane stresses. There are there are two types of plane stresses, right? There are two types of plane stresses. So which are those? There are two types of plane stresses. So the first one is called as like plane stress, like plane stress, right? Here the important characteristic is the nature of stresses acting, the nature of stresses acting will be same, that is either tension or compression, either tension or compression, right? So it may be in both the directions. When I say plane stress, it may be either sigma x, sigma y, sigma y, sigma z, or sigma z, sigma x. In all the cases, if the tension or compression exists, right? So then we call it as like plane stress. You can note this, it is or. A combination of this is not allowed, right? Either it should be purely a tension or it should be purely a compression, right? So second type of plane stress is unlike plane stress, right? Here the nature of stresses acting will be opposite, right? Or you can call it as different. So here you will be getting a combination. Okay, so that is regarding like plane stress and unlike plane stress. Next we'll be going for complex stresses. Complex stresses. So it is important for us to know what is a complex stress, right? Now complex stress is very easy to define. It is nothing but plane stress along with shear stresses, right? Plane stress along with shear stress. Plane stress along with shear stress, right? So that combination we call it as complex stresses. Now I'll just draw the case of a complex stress here. In this case, right? So in this case I need to load it, same as in case of the plane stress, because it is nothing but the special case of plane stress. So loading will be in two directions for plane stresses. So it is sigma y, it is sigma x, right? Apart from this you will be having shear stresses, right? Apart from this you will be having shear stresses. So shear stress, I'll mark it here. Okay, so this is tau xy, this is tau yx, right? So this combination I call it as complex stress. It is a combination of plane stress along with shear stress. Okay, that was regarding complex stresses. Thereafter the associated strain we call it as complex strain, right? So in the next session we'll be looking after how to analyze these kind of stresses, that is especially complex stresses and biaxial stresses, that is plane stresses, right? So there are two methods which we'll be using. So in the next session we'll be looking after which are the two methods and which one is more easier and gives accurate results. So that's it for today's session. Thank you. Have a good day.